Hello student, this is the class of BSc 4th sem of Davangere University, and this is the session is related to the problematic solutions on the diffractions. By the way, I am Dada Pires from Government Degree College Chanagiri. In this session we are solve some main problems related to the diffraction module. Let's see. A narrow slit is illuminated by a light of wavelength is located at a distance of 0.1 meter from a straight edge. If the measurements are made at a distance of 0.5 meter from the edge, calculate the distance between the first and second dark band. This is the problem related to the diffraction at a straight edge. And we have from the straight edge, we can be width of the dark band first band formula is given by xn is equal to square root of b at a plus b into 2 into n lambda. A is the distance between the source and the edge, and b is the from the edge to screen. N is the number of order and lambda is the wavelength of incident one. And for the first and second order, their difference, the distance between the x2 minus x1 is equal to b into root a plus b 2 lambda, and n is the second, that is root 2 minus first one is root 1, that is 1. Putting the value of b and a and lambda, that gives the b is the 0.5 meter, a is 0.1, thus b means 0.5 into 2 into lambda 5890 into 10 to the power of 10 meter divided by a is 0.1 into root 2 minus 1, and gives the their unsolving or simplification, we get the x2 minus x1 is equal to 0.0786 into 10 to the power of minus 3 meter. These are the distance between the first and second bright dark bands. Second problem, so what is the radius of the first zone of a zone plate of a focal length 0.2 meter and for a light of wavelength of 5000 angstrom. Here is the problem related to a zone plate. The given is the focal length is given here, f is equal to 0.2 meter and the wavelength is 5000 angstrom. Angstrom is nothing but 10 to the power of 10 meter, but 5000 here, that's why 5 into 10 to the power of minus 7 meter, or 5000 into 10 to the power of minus 10. You can be write anywhere. 5000 into 10 to the power of minus 10. You can write also, or 5 into 5000 can be into 5 into 10 to the power of minus 7. So then apply this equation. F1 is equal to Rn square n lambda. F1 is equal to R square by n lambda. R square is the radius of nth order, n is the order, lambda is the wavelength, f is the focal length. For the first order, n changes to 1, hence R1 square is there. So R1 is equal to square root of f lambda, that is equal to f is 0.2 meter into lambda 5 into 10 to the power of minus 7. This value gives to 0.316 centimeter is the radius of a in centimeter is the radius of a first zone plate. So determine the radius of the first half period zone of a zone plate which behaves as a convex lens of focal length 40 centimeter for a wavelength of 5000 angstrom. The wavelength of 5000 angstrom is the zone plate and focal length is 40 centimeter. So the solution, the given problem have solution is R1 is equal to square root of f n f lambda. N is the first order, this is n is equal to 1, no doubt it is a n, but n is 1, so there is no problem. So F is 40 into centimeter. This is converted into meter. 40 into 10 to the power of minus 2 meter. There is the, oh shit, I use the 5000 angstrom here. So on simplifying, the value is 4 point something. 8 is 4 200. Uh, 4 point some extent 4.4. Let's say move further. A single slit width of 1 mm is illuminated by a light of wavelength of 589 nanometer. Find the angular spread of the central maxima of a diffraction pattern. Find the angular d theta can be found out here. Angular spread. So it's a single slit experiment. In this, width of a slit is given 1 mm. So the central maxima is due to single slit extent from axis of the slit to the first minima on either side. Usually experimentally ನೋಡಬೇಕಾದ್ರೆ ಹೀಗೆ ಫಸ್ಟ್ ಇರುವಂಥದ್ದು ಇದು 0 ಅಂತ ಇದ್ರೆ, ಸೊ ಈ ರೀತಿಯಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಸೆಂಟರ್ನಲ್ಲಿ ಇರುತ್ತೆ. ಆಮೇಲೆ ಪ್ರೈಮರಿ, ಸೆಕೆಂಡರಿ ಈ ರೀತಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುವಂಥದ್ದನ್ನ, ಇಂಟೆನ್ಸಿಟಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುವಂಥದ್ದನ್ನ ನಾವು ಕಾಣ್ತಿದ್ದೀವಿ. So on either side, the formula here is the given is 589 nanometer and width A is 1 mm, that is 10 to the power of minus. For the first minima, we use the A sin theta is equal to n lambda. N is the first, that is 1 lambda by A, that is so sin theta 1 is equal to lambda A. So lambda is 589 into 10 to the power of 9 meter and A is 10 to the power of minus 3 and sin theta is equal to 0.00589 and theta 1 is sin inverse of 0.0589, so that gives the 0.033. Hence the objective of an astronomical, next problem, see, the objective of an astronomical telescope is 30 centimeter diameter, assuming the mean wavelength of white light is 660 nanometer. Instead, we find the resolving power from this problem. Solution is given. The objective d equal to 30 centimeter, that is 30 into 10 to the power of minus 2 meter and mean wavelength is 660 into 10 to the power of 9 meter and 10 to the power of minus 2 meter. So resolving power anna angular separation anna d theta is equal to 1.22 lambda divided by d. So on equating the 1.22 into lambda value, d is the diameter, that is 30 to 10 to the power of minus 2 meter. So d theta value, on simplification, we get the resolving power d theta is equal to 3.69 into 10 to the power of minus 5. We move for further. A parallel beam of sodium light is allowed to be incident normally on a plane grating having 4 to 5 lines per centimeter, and a second order spectral line is observed to be deviated through angle 30. Calculate the wavelength of the spectral lines. So theta is given 30 degree and A plus B is 4250 per centimeter. Per centimeter means per centimeter ಗೆ 4250 ಆದರೆ ಒಂದು ಎಷ್ಟು ಪಾರ್ಟ್ ಅನ್ನ 1/425 ಟೈಮ್ಸ್ ಆಫ್ A plus B ಒಂದು ವಿಡ್ತ್ A plus B ನ ವಿಡ್ತ್ ಏನಿದೆ ಗ್ರೇಟಿಂಗ್ ಲೆಂತ್ ಏನಿದೆ ಅಂದ್ರೆ 1/425 ಇದೆ. So A plus B into sin theta is equal to n lambda, but order is 2 in the second order ಇರೋದ್ರಿಂದ n is equal to 2, that is 2 lambda. That lambda is equal to A plus B sin 2 theta. So we can be calculate the wavelength lambda is equal to sin 30 by 2 into 1 by A plus B equal to 4250. As the lambda value we get some extent 586 like this way. As we calculate the angular dispersion in degree per angstrom for a diffraction grating having 14438 times per inch when used in a third order at 4200 angstrom. So given solution is for order n is equal to 3 and angstrom, the wavelength 42 means 4220 to the power minus 10 meter. Number of lines per inch is 14438, 14438. But formula we know that A plus B sin theta is equal to n lambda. For sin theta is equal to n lambda by A plus B. Putting these values, sin theta n is 3, lambda is 4200 into the power of minus 10. A plus B is there, but actually per inch means per inch 1 inch equal to 2.54 centimeter. Centimeter can be converted to meter, that is into the power of minus 2 meter per divided by 14438. On simplification we get the value of sin theta is equal to 0.763. On this theta is converted into cos theta, that cos theta is equal to 1 minus sin square theta. So that is 1 minus 0.7163 square, that's its value. Cos theta is equal to 0.6978. The angular dispersion can be calculated. D theta is equal to n into d lambda by A plus B cos theta. N is the order of 3, d lambda is the 1 angstrom for the change in the wavelength of a angular dispersion is 1 angstrom. So using this 3 into 21 into 10 to the power of 1 angstrom means 1 into 10 to the power of minus 10 d lambda. So A plus B usually 2.54 into 10 to the power of minus 3 divided by 14438 into cos theta is 0.6978. Put this value and we got the dispersion, that is 0.114 centimeter. So further in this way we solve some problems, so we can be cover some physics more problems on the college physics by Sundarajan, Muhammad Aziz, and also be CL Arora of physics for degree students. You can come across such reference book and you get some more examples to solve. Okay, I hope you understand these problems. Make a problem should be, make a formula must be, you must know at any time, then it can be solved easily for the. Okay, thank you very much.